Hi everyone, my name is Anil Nahata and I work as a principal solution architect in Messaging Org. And today we are going to talk about Oracle Cloud Infrastructure Queue Service. So we are going to talk about benefits of OCI Queue Service. OCI Queue Service is a fully managed high throughput queuing service capable of ingesting millions of messages per second and highly available. User can publish, consume, delete messages and also update visibility of the message. It helps to decouple applications and scale them independently. OQS eliminates overhead of message-oriented middlewares, and it also supports REST and STORM protocol. STORM stands for Simple Text-Oriented Messaging Protocol, and it's asynchronous. And we are also going to talk about message visibility, which is a very important feature of Queue. And so when we user put the message in the message queue, the message becomes durable and persistent, and message is visible to all consumers. Once any consumers get uh, calls get message API, the message is written and message is considered in flight. Now, once the message is written, it won't be visible to other consumers, and it will be only visible to that consumer which is which got it in the get message API. And every message has a visibility timeout defined, and it can be also extended using the update message API. So when the visibility timeout is there, the same message won't be written to another customer. And once we do the update message, the visibility timeout can be increased, and the consumer can take more time to process it. Once the visibility timeout expires, the message is considered visible again, and other consumers can consume it. So again, another consumer calls the get message API, the message is written, and the visibility timeout starts, and the consumer is able to process the message. So consumer acknowledge message by calling the delete message API, and the message is marked for deletion. So after that, if any consumer calls get message API, the message won't be written. So message is neither in flight and nor visible. So that's the whole life cycle of message in the queue. So if we see on the left hand side, we have a producer which can be hosted anywhere, and the producer can be anything. It can be a simple application which is hosted on your desktop and sending message, or it can be a web application which is sending message to OQS, or it can be any other application which is interacting with the Oracle Queue service. So producer is sending messages. So message can be anything, Oracle Queue service. On the right hand side, we have a consumer app which is hosted in Oracle Kubernetes Engine. So consumer app typically consumes the message. When we say consume the message, it processes the message. So processing messages can be done in various ways. I mean, it can pass it to the further any other consumer app, or it can save it in the database. It can save it in object storage, or it can send it to the further any other queue or any other service. However, in this case, we are just going to process it to showcase how the message is processed. And then we are going to acknowledge it back to the Oracle Queue service that the consumer has successfully processed the message. And we will send the acknowledgement, which is basically we are going to make a delete call. Now, we will also see that how consumers will scale up based on the queue size. Queue size, we are going to check by using a Oracle function, which is exposed using a API, using API gateway. And it calls a queue status API of the Oracle Queue service. And based on this, based on the number of messages in the queue, we scale the consumers. And how the consumers are scaled up, we use a metric-based scaler, which is called CADA. CADA stands for Kubernetes Event-Driven Autoscaler. The number of messages are increasing in the queue. It start scaling up from 1 to n, like we have set the limit, and it is start scaling the number of consumers. And once the number of messages starts going down, it starts scaling down. So let's walk through console of queue, how it looks like from console. So I have already queue in place with the display name Anil compartment queue, and that's my queue OSIT. So you see the queue here and then the reason name here. Maximum retention period where the message can be retained is 4 days, and it is again configurable. Number of delivery attempts are 5. So when I say delivery attempts is when how many times you can call get message API. So let's say if same message is written 5 times using get message API, but it is not acknowledged. Acknowledge in the sense it is not deleted from queue. Then it will go to DL queue, which is dead letter queue. So dead letter queue comes along with every queue, and it's just in the end it is hyphen DL queue, and it's a regular queue but attached with the every queue, and whatever the messages which are not processed after number of delivery attempts configured, it will go to dead letter queue. And the visibility timeout which I have done, which I have set is 2 minutes. And you can also configure the queue. You can change certain things like visibility timeout and the dead letter queue settings, how many delivery attempts you want. And you can also purge the queue. So many times, let's say you are just testing the queue, so you can delete all the messages from the queue. So this is called purging. And dead letter queue, you can see that if you see the OSIT, it is it's the queue OSIT and hyphen DL queue. And it's again dead letter queue is a regular queue, and it works in a similar fashion like a queue. And also you can see it if you just go to top level view, you can see the multiple queues here. And right now I have filtered it in any state, but you can also filter it based on various state which we have, like failed, deleted, deleting, updating, creating, active. So right now our queue is in active state. So we are going to talk about queue producer code and how it works. So this is a Java code which we are using, and it will be hosted on a virtual machine. Since we are using a simple public static void main, so it's a straightforward code, and we are using Queue standard SDK, and we are using a Queue client to get authentication provider, and then we are setting the data plane endpoint. And then we are keeping an infinite loop to keep sending the messages at a very high speed. And we are getting ready a put message request. So put message request puts 20 message in one go, and returns the object put message request after populating all the requests. And pause that. I have put some states as well, where we are counting the total message count so that we can keep the track. Also, I am including how much time it is taking, so we can see the latency in the same region. Since the place where we are hosting this Java program, it is on a virtual machine. It is in the same region where queue is hosted. And finally, we are going to print this send latency of each of our put requests. which will be typically in milliseconds, less than 100 milliseconds most of the time, and the total message count, which we are sending using this producer. We are going to talk about Queue Consumer and how it is configured in Oracle Kubernetes service. So we are using, so this is a Java-based program which use the standard Queue SDK. We are instantiating a Queue client, setting the Queue DP endpoint, which is data plane endpoint, and some logs are in place, and reading the messages in infinite loop. It use the get message request, and we have a method which calls prepare get message request. And if you see, I'm doing a long polling by setting the 20 seconds, sorry. And I also put the message limit to 20, which is the maximum messages which a single get message request can get. And post that, I'm returning the get message request. And I'm putting some state, how much time it took to basically get message request, and as well as the processing time. And post that delete message. Finally we are going to acknowledge all the messages. So, and then we are processing the messages. So for the time being, the processing the messages, I'm not doing much here. So I'm just putting the thread.sleep, which is for 1 milliseconds, to replicate how the message is processed. In real time, the message can be processed in multiple ways. It can be stored in database. It can be further sent to any other queue, or it can be stored in object storage, or you can do many things with the message. And once the message is processed, I'm just adding the number basically for delete message entry, so that finally we can send all the message process in one go, so that it saves us the cost when we do the batch call. And once we have processed all the messages, I'm calling batch delete messages. I put some logs batch deleting messages, and again it's a client data plane client call, and we are calling the standard way of doing the delete message. And finally we are printing some states. So let's take a look about how this consumer is hosted in Kubernetes. So we are using a deployment, and it's a standard. We have defined some metadata here, labels, so that we can match the labels in the selector. And you can see the selector match labels QOK, which we are doing here. And the spec, QOK is the container name, and the image, it is again, since it is going to be a Docker image, it is going to be hosted in a container registry. So we are just giving the container registry name here. Image full policy is always, and then the ports we have defined 80, and the environment variables, some environment variables, data plane endpoint, which we are using in the Phoenix region, and the QOCID. And also we are to pull the image from repo, we are using the secrets, which are username and password, which are stored separately, and we have configured it here. Also, since we are scaling up and scaling down our consumers, so we are using a kind which is called scaled object, and which is a standard definition of OK. And it's a typical metadata HTTPSO, and deployment name is Q deployment SO, and the polling interval, which it is going to poll the, since it is going to poll an API which checks for queue length, so it will do in every 5 seconds. Maximum replica count, which it will basically max number of consumer port, which it is going to scale up is 75. Idle replica count is 0 when it sees it doesn't see any activity in the queue or there are no messages. It will be idle, and we will soon see it in action. Minimum replica count is 1. Cooldown period is around 2 minutes. And scale target reference is QOK, which we have just defined as our consumers. And we are also exposing an API using function, which is exposed using metrics, which is using exposed using API gateway. And when we get and the message size, visible message size, which we have put is 200. It will start scaling up, and that's the URL for that's the API gateway URL which we have given, and that's the value location because we written the JSON as a get state API or any other Q API. We return the JSON, so that's the JSON path which we are giving. So we are going to talk about queue length function, which gives us the queue length. And it tells us visible messages, in-flight messages, and the messages in the DLQ. So we are calling basically get state API. We are using Java-based SDK, and let's see how it is done. So since we are using a function, so we are using a resource principal here, and resource principal authentication detail provider. We are using an instance of it. And then we get a DP client by providing the instance of RP, setting the endpoint, and calling the get request API using DP client.getState and just converting it into JSON using JSON API and returning the JSON output. We will see the now producer consumer demo in action, how our consumers are going to scale up, and how the consumers are going to match with the speed of producer. So just we will see how the get state API works. So let's see get state, and then we will start our producer. So right now we can see the visible messages are 0. So I'm doing it in every 5 seconds in this check. And visible messages are 0, in-flight messages are 0, DLQ visible messages are 0, and DLQ in-flight messages are 0. So it will soon start increasing, and I'm going to start the producer. But before we start the producer, let's see our consumers. So right now we have, this is my deployment, and deployment name is QOK, which I have just explained. And you see right now we don't have any ports because there are no messages in the queue. So once we start pushing the messages in the queue using producer, soon consumers will start scaling up as messages start going down or going up. And I'm starting producer now, which is hosted on a virtual machine. And I'm starting producer, and you can see it will be pretty fast. We will also see the message latency, which is in typically in milliseconds, less than 100 milliseconds in the same region. On the right hand side, we can see now the visible messages are increasing. Right now there are 0 in-flight messages, and in-flight messages now will keep increasing. Right now the visible messages will be more because consumers will take some time to catch up. You can also see the latency, which is less than 100 milliseconds. It is in 20 and 30 milliseconds. And the total message count is increasing, but our in-flight messages are less right now. And let's go to consumer side and see how. So now our consumers have started scaling up. You can see that right now we have 8 ports ready. So new ports are getting created, and you can see how fast our new consumers are getting up and running. So we can see the visible messages are increasing and so are our in-flight. It will take some time to catch up because if I can recall, I have introduced a 1 millisecond delay for every message so that consumers can process the message, as well as I am also calling the delete message API. So due to that, there is some amount of delay on the consumer side, but on the producer side, we don't have any delay and we are sending 20 message in the every call. So that's why we have the higher the number of consumers, but single producer uh, on the producer side. And let's quickly check the, so we can see that we have number of ports which are running is 64, and we have all 75 ports are in place now. And let's see the visible messages. So right now it's 30,000 messages, though the producer has pushed around 100K messages, and soon producer and consumer will match the speed of producing and the consuming of messages. And number of in-flight messages will increase as we move forward. The specific logs like this, which we have just shown that how each consumer is processing the messages, and the estimated time and all those things are in place. So we can see that we can also view the visible messages from Queue console, and it's auto refresh. So now consumers are matching with the producer soon, one level up, and you can see it from here also. And as well as you can see there are no messages in the dead letter queue because all the messages are getting processed successfully. So we can see that number of visible messages are going down and the number of in-flight messages are more now. So soon we will see that number of messages are probably in less than 100, or it is getting consumed as soon as producer is producing it. So see some of our ports are restarting.